everyone. So today I will talk about essential security checks for your Go project. Before I start, a bit about myself. I'm a long-time Go developer, open source contributor. I maintain this tool gosec, a security static analyzer for Go language. I was also a founding engineer and maintainer of Jenkins X, continuous delivery platform for Kubernetes, written in Go, and a bunch of other open source contributions. So before we start, I would like to check a few things. How many of you do you have security checks in your projects? Please raise your hand. Not that many. Surprised. Okay, so how many of you do really run a static security analyzer before committing your code? That's also, so few. I'm surprised. I was expecting that a lot of people. How do you consider the security of your dependencies? Do you scan them? Do you scan the vulnerabilities of your dependencies? Please raise your hand. Okay, a bit more. That's great. Okay, so I hope at the end of this talk, I will convince you that adding more security checks in your projects it's beneficial. So these are mainly the areas we will touch today. So we will look at code security a bit from static code analyzer perspective, but also we will touch a bit on fuzzing. Then we will talk a bit code dependencies and security of dependencies, how we can scan for vulnerabilities and react when a new vulnerability occurs. And we will conclude with how we can secure our releases, how we can sign our binaries, and hopefully at the end we will have some time for some questions. So first area is code security. When we think about, we think probably from bugs perspective, from security bugs perspective. There are a lot of application security issues which are typically found in any type of language, which are also present in Go. So if we just look at this list, we have a lot of, maybe you are familiar with some of them. So I believe input validation, it's some area where you maybe heard about. Also SQL injection, any kind of injections you are probably familiar with, and I hope at least. Another area, especially in a cloud environment, is server-side request forgery, where we try to protect that we inject, for instance, URLs which are not trusted, and someone can extract information or access that URL. Also we have like unsafe crypto. We use not really, let's say, secure crypto configurations. Then more typical issues like hard-coded secrets and in-code. Hopefully less people do this kind of stuff today. They are also in configurations and so on. Also denial of service, it's quite a common issue. And maybe cross-site scripting, if you use Go templates, is also an area to look at. TLS configuration as well. I think the client side of TLS is much more secure these days in Go, so it's much difficult to start with an insecure configuration. So I think Go team did a great work to come with very good defaults for client side, but still you can, let's say, configure insecure ciphers and expose yourself. So let's have a look a bit on input validation. So it's like the first rule of application security, right? We want to make sure that we don't get any malicious content in our application. So if you look a bit on what are the sources of our input, it's it's quite complicated, right? We have a lot of places. Some of them may be easier to spot, others are not that easy. So you can see that we can get data from many, many places, and I believe a lot of Go application and services that they get input from these sources. So like environment variables, command line arguments, these are very typical. Sometimes query parameters, URL values, HTTP headers, cookies, form data, files, and so on. This is just like common places, and to be honest, it's really difficult to keep track of these places without having some automation. Also, if you look on the injection side, it's more or less the same. So we have typical SQL, non-SQL injections, command injections, also all typical reflected XSS and stored XSS and so on through Go templates. There were some issues recently. So what we can do about this, our probably first way to rule out these issues is to do security review, code reviews. I believe a lot of you do code reviews. I'm not sure how many of you really do security code reviews. So this is a good start to have code reviews and look at the code, but sometimes we miss issues. If you have access to security engineers, which are more, let's say, security minded, and they can see the issues and spot the problems, it's great. Most of the teams, they do not have access to this kind of resources. Also, it's not enough. You cannot really scale, so it's quite complicated when you have a large development team and a few security engineers to really look on every change, on every pull request and have a review. So it's difficult. It's mainly you can do a code audit on a, let's say, regular basis, but not continuously. So it's hard to keep up with the development speed, and also human error. It's a problem, right? So even a very experienced security engineer can go over your code, but still don't spot the issues. So what's the solutions? The solution is to have some automated security checks and some automated security code analysis in our build. And hopefully we can rule out some issues which are really common. And I hope we will fix these issues before we merge our code, especially if we see critical and, let's say, high issues. They should be fixed before we merge our code into let's say, main, or depends what your source code system is. But it's really highly recommended that you fix them, because in this way we can keep the whole security tech depth low. And I think when we look at the static code analyzer, having a low false positive rate is really important, because imagine you have a high rate, then you cannot trust that tool anymore. So it's just noise, and at the end of the day, you cannot use it, right? So that's really, really important. On the other side, we need to be aware that also a security static code analyzer is not able to find all the security issues, right? It's not bulletproof. There are false negatives which still are in your code. There are still security issues which are not uncovered by the static code analyzer, right? So it's definitely not 100% sure that all the security issues are found. I think also the speed of the scanning is very important, because we want to get fast feedback. We want to fix our issues. Ideally, we want to shift as much as we can left. If we can really fix them before even opening your pull request on your editor, it's even more productive, right? So, and I think there are a lot of linters and linters aggregator which makes this easy. And most of them, they are integrated development environments. Also having a standardized output of the scanner. So there is this Sarif output format, which was standardized across industry, is used by proprietary static code analyzer, but also open source. It's quite important because it allows us to integrate these tools in a much, let's say, larger ecosystems. Like you run it on GitHub, you want to get the security findings in the GitHub checks. Also, it's important to have a good infrastructure for this tool and have integration support, like, I don't know, container images that you can quickly run the tool in your environment or GitHub action if you are on GitHub. So what are the options for Go? We have this open source Go security analyzer. I'm not sure if you are familiar or did you hear about it? Please raise your hand, and not many people know. I think it's used a lot underneath, used by these linter aggregators like GoLab, GoLang, CI linter. Sometimes you don't see it, but if you get a security issue or you get a false positive, you will learn about it, I guess, and then you will go and check the site. So it's quite used and broadly deployed in a lot of places. So it's a static code analyzer for Go. It's open source, was maintained by a community by, I think, more or less 7 years now. So what it does, it inspects the Go abstract syntax tree, and more recently the SSA, the single static assignment code representations. And it ships with a rule set, which is built into the tool. So it ships like a single binary. We have a bunch of rules which are built in. This makes it a lot easier to run your code, so you do not need to run it. Sorry, you don't need to provide any configuration and stuff like that. So it's self-contained. It's very fast, so you can really scan large code bases in a very, very fast time. Looking at other competitors, it's really fast due to the fact that everything is built in Go and is built in. Yeah, we have a Go action. We have image container for it, so it's pretty easy for you to integrate it in your workflow. And as I said, it's integrated in a number of tools. There is maybe this GoLang CI link tool, which aggregates a lot of other linters. It's also in GitLab, and so on. It provides Sarif output and a lot of other outputs, not only Sarif, like JSON, YAML, and so on, depends of your setup, but Sarif is probably the most standardized and used. So we are a small community, so we are always happy to accept contributions and, yeah, even sponsorship. We have a roadmap. We have a number of bigger features we want to implement into the tool, and yeah, we are always welcoming to any kind of improvements. So now let's see it in action. Do you see this? We have this sample of code. Do you spot the security issues here? Do you see something? Oh, when? Sorry?
Maybe the port number should have been environment variable.
Yeah, maybe, but that's not really a security issue. Yeah, that's a security issue. That's a quite let's say severe issue in a cloud environment. We get the URL from a query parameter. We don't validate it. We don't sanitize it, and we make a request with this URL. So imagine you are in an environment where you expose, I don't know, internal services. So an attacker can inject their URL of a local service and can query that service through our backend, basically. So it can, for instance, I don't know, check if you have running services which you don't want to expose. So that's a typical server-side request forgery vulnerability. So now if we run gosec on this sample code, we see that it finds the issue, and it provides us a nice output, basically. And it tries to provide also some indication regarding severity and confidence and so on. So this looks like when you run it in command line, we don't get an output. It's just you get the line where the issue is. So we have basically 36 rules which are built in. You can see the whole list on this page. Yeah, there are a lot of rules which are not are on our to-do list, but these are rules which they survive over time. We try to map each rule with common weakness enumeration. This is like a security standard for, let's say, code vulnerabilities. As I said, rules are written in Go. They are really fast. They run concurrently. So as you can imagine, you can have a project with many, many packages. So in order to speed up the scanning, we run these rules in parallel on different packages in the project. Yeah, they inspect either the abstract syntax tree or the SSA code representation. We will have a look in a minute on each one. So as SAT was long time in the Go toolchain and available, so the tool originally started with abstract syntax tree. Yeah, it's relatively fast, and it's, let's say, it works well with security issues which are more contained when, like previously we saw this server-side request forgery, so it was like easy to spot it. But when you have a call graph which goes across multiple functions, with AST it's quite difficult to find the issue. Like especially when you want to track back a source from a data. So if you want to do some data flow analysis and really find from where this data is coming from, so something like taint analysis is really common. So in that situation, SSA is much more suited for. So we will see in a minute. So this is how AST-based rule looks like. It's quite simple. So you have you define the rule as a new type you see above, and then we construct this type, and based on the rule type, we have different logic. In this situation, we see we have this list of HTTP calls we want to match. So in AST, for this, the compiler translates a call into this call expression. So in this situation, we want to match all call expression for these calls. And then in this match method, this match method gets called for every call expression into the AST graph. And then here we can implement our logic. So in this case, we just check that we have a call in this list, and then we issue a security finding. So now, this is how abstract syntax tree looks like in Go. This is just a very small portion which I could fit on this slide. It's really large for let's say even for a small function. So you see there is this call expression on the top, and then under this call expression we have a selector, and then we have the function name, and so on. So when we match basically into the function, we will get a whole call, we will get a whole tree under this call expression in our match method, and then we can make different kind of logics. We can base our logic on that. Of course, we can also work the tree back up, but it's much more complicated, so it's not that easy. Like, let's say if we want to have a way to really analyze the flow, SSA-based rules are much more suited. And I think in the, I don't know, 2-3 years ago was introduced in a Go toolchain. They introduced this analysis framework, which allow us to use SSA code representation. So it's basically Go toolchain transforms the AST representation to an SSA representation, and then we can use that to perform static code analysis on that. So here we have the same example with the HTTP. So you see in this case, it's a bit different. In SSA, each function is a block of instruction, and we need to check its instruction, what type of instruction it is. So we are looking for a call, and then we can get the function value and then function name, and we can match on this. So this is basically how it looks like. You see there are assignments. So the idea is that you don't have for each each assignment is separate. So in this case, we see that the HTTP GET call is at the top, and then we see that this function returns two values. We see from the response and an error, and then these are extracted, and then we can basically base our analysis on that. And then you see, as we go down, we see all the logic of the SSA. So basically now, how can you integrate it? As I said, it's very easy. So we have a GitHub action, we have an image. So basically, this is an example with GitHub workflow. If you use GitHub, it's really easy. So basically, you just add it in your steps somewhere after you check out your code. And then in this example, we run a scan, but we want to generate Sarif in order to really integrate it with GitHub security checks. So we generate Sarif, and then we upload Sarif on GitHub. So this is all you need to do. So it's 4 lines of YAML. You put it in your GitHub action, basically, and then you have everything integrated. Okay, so now let's look a bit on something else. Let's look on code fuzzing. Go has a great fuzzing infrastructure, which was recently introduced. So what is fuzzing good for? Maybe some of you are already familiar. I would say it's really good to discover vulnerabilities or crashes. So fuzzing essentially is generating random data which gets injected into your function, and then you can, in this way, find vulnerabilities or crashes. And especially for code which is really complex, so which you cannot really unit test it. Imagine you have a code which you don't really see the flow. It's not that easy. You don't have just an if, and then you can quite kind of very easy unit test it and then have a 100% coverage on that code. So let's say if you have a parser or more complex code, I would say fuzzing is really beneficial for finding issues. And there are plenty of issues discovered with fuzzing, like SQL injection, buffer overflows, DOS, XSS, and this is only in Go, so we don't talk about C++ or other more languages which are, they have a lot more issues. So basically how fuzzing works in Go, you have this initial corpus, and then you start with something which is meaningful for your function logic, and then it's able to generate additional corpus using compiler-guided coverage. So it basically it generates random values, and then compiler checks that areas of your code gets executed which they were not executed before. And in Go, all this test data is saved in this test data fuzz, and then the name of your function. So basically, this fuzzing framework has two modes. So when you already have this generated corpus and you just want to run it as a unit test, and you just run the fuzzing, and then you have a mode where you generate, when you run it, to generate more corpus, basically. So there are great resources from Go team. There is a great tutorial and also an introduction. So basically, I put here a snippet from this Go tutorial. So you see a function basically, when you write a fuzzing test, it's more or less like a unit test. It's very, very similar. You are probably very familiar. The main differences, you see that there is this input values, in this case I and S, and basically the fuzzing framework will randomly generate these values for you. So you just need to call your function which you want to fuzz, and then check the output of that function and check if somehow an error is generated without expecting it, right? So that's basically, that's a really basic usage, but it's really easy to use it. So I would say it's a great complement to unit test, especially in areas where you think that you might have issues which you don't see. Okay, so now let's move to another area. Let's look into dependencies security. This is like, I think in the last years was a hot topic about supply chain security. We pull dependencies in a project from many sources. We don't really look at them. Was also mentioned today in this keynote. Go team, they build this checksum database, and is integrated in Go module. They check the integrity of these dependencies so that we make sure that we really pull what we expect, and nothing is modified on the way. There is also this GoSumCheck tool which you can use and additionally check your Go module and see if you have discrepancies or you have issues. Maybe another recommendation is that you can use a dependency bot. I think these days is very easy, especially if you are on GitHub or other let's say codes hosting services. There are plenty of options. So this, I would say, this is easy to set it up, and also makes your life a lot easier because you can incrementally upgrade the, let's say, dependencies when every time a change comes up. Not necessarily a security fix, but yeah, it's a good way to stay up to date with your dependencies. Also, I think it's also a good practice to keep your Go version up to date, because as you saw recently, there are more and more security fixes released by Go team. There are a lot of minor versions coming out, not every 6 months, but they come every time they discover an issue. So it's better to update. And also they developed a great tool, this govulncheck, which is really nice to use to scan your dependencies and discover issues you have. So you have dependencies which you need to update because of security issues. So this govulncheck, it's interesting because it uses also static code analysis techniques to really identify the dependencies you have in your code. So let's say it's not blindly looking just on your Go module, and then if you have let's say a package in your Go module which you use, but it's not really instantiated in your code, but it's somewhere there, it will find out. So it's basically first trying to identify which dependencies we really use in your code in different ways. And then they have this vulnerability database which they keep it up to date, and it goes into that database and it checks if your dependencies, they do have known vulnerabilities. And if they do, then basically it will return you more information about those vulnerabilities. Yeah, of course, it has some limitations, especially if you use reflections and stuff like that, so it's not able to, in that case, to really identify the dependencies. But in general, I think it does a great job. It's relatively easy to install it. You just install this tool, and yeah, you can also make it part of your build. So basically, you can fail your build when new vulnerabilities are discovered. So we can have an output example here. So we have a project we scanned with govulncheck, and this project was still using Go 21.3, and in 0.4 there was a security fix. And when we scan, we see we can see the trace of the call graph, and we see where we potentially call this vulnerable file path package. And this kind of reassures us that our code is really vulnerable, so it's not really, let's say, a false positive, and we really need to update. Also, it returns you more information related to this vulnerability and some sort of severity. Okay, now last section, let's have a look on release security, how we can secure or secure our binaries and application before we ship it. I would say these days quite easy to sign your binaries and application. There are a number of tools available. Maybe you heard about this cosign, sigsotre. It's also an open source tool. Another, let's say, important part of this release security is the bill of materials. So it's great if you can generate this bill of materials and bound it together with your application, and then use a tool like cosign to sign everything together. And this tool has different modes, basically, so you can generate a key pair. You can put that in a KMS service, for instance, or you can use an OpenID Connect and use a keyless setup. So it depends what works for you. So in this example, we generate a key pair, and it's then stored. Like, for instance, if you use GoRelease to release your code, it's relatively easy. It has a design step, so you can use cosign and then provide the key and generate the signature of your artifacts. So you can basically generate the signature of your all artifacts, including the BOM, and that's automatically, for instance, if you are on GitHub, stored together, and then someone can take it and verify it. Also, a great advice is that if you release container images, please also sign it. It's quite easy to sign them. So this is an example how you can sign. For instance, a Docker image is just one line. As soon as you have the key, the tool will sign the image and put the signature directly on the container registry. I think they support a lot of container registries and different setups and configurations. So that's a great integration. So that, I think, this concludes my talk. And now, if you have questions, happy to take them. So you can see in this repository, you can find the slides and all the code samples. So yeah, happy to take any questions.
Hi, I'm Doug. I was wondering, there were 36 rules in gosec. How often do new rules appear, and what's the process there? There are not as many as I expected there to be.
Yeah, it's true. It's not that often, but the process is quite straightforward. We just open a pull request with a new rule we review it and we merge it basically. So that's the process. We don't really have a, let's say, a configuration language for these rules like other tools have. For instance, if you are familiar with SamCrep or I don't know, Sneak or whatever more commercial tools, they do have a language for these tools, and then they have a repository, and then you can fetch, you need to pay. But in our case, it's quite self-contained. You just open a pull request with a new rule. Usually, yeah, if we see security issues which they occur in code, and we see it as a pattern, we try to create a rule for that.
Thank you. So, one question is, if I want to contribute, for example, there's maybe I don't know what rule to create. Do you have a list of rules a wish list of something like that coming from other applications out there?
We have a number of issues on GitHub with some suggested rules, which are open, so you can pick up one of that. You can also come on Slack, and we can chat if you are interested. There are a number of open issues which are just with rules, and I think they are tagged with rule, basically. So
great, thank you.
I mean, the challenge is that sometimes there are security issues, and then you think, okay, I want to build a rule for that, but then, for instance, Go team, they will fix the issue into exactly where the problem is. Sometimes they don't, and then you think, okay, it makes sense to add the rule or not. So that's always a challenge. So, but if the issue still exists, we are happy to get a rule. And also we had rules which we deprecated, for instance, because the issue was fixed and then made no sense to keep the rule.
Is there any like a guideline of best practices? Because we starting adopted these gosec, govulncheck tools, and okay, like when it comes to gosec, it works in build time, but when it comes to govulncheck, it must be run continuously because the vulnerable the issues being discovered continuously over time. So is there any steps we should follow, because we kind of struggle when and where it should be run, these tools?
Yeah, so I can speak from my experience with govulncheck. So I integrated in gosec, and I integrated in the continuous integration steps. And I think it's useful because sometimes you just work on something, right? You contribute, and then you do this code change, and then you see, okay, now I have also vulnerability in my dependencies, and then you go to fix that. It might be that you have a dependency which is breaking changes is not that easy to fix and require more work, but at least you are very fast aware that, okay, I have this issue, maybe I cannot fix it now, but I have it, and I try to fix it. I think the tool itself is not very sophisticated, so you cannot really add exceptions and stuff like that. So when it fails, it fails. You need to fix and update, and then I was using it as continuous delivery, so continuous integration step, and try to fix whenever, let's say, an issue pops up. If it's easy, I just bump the version, and then. You mean like a microservices? With microservices you have in production, and then you want to fix it. Here it depends of your, let's say, deployment cycle and how you deploy that microservice. But ideally, yeah, you need either to monitor this database somehow, because this tool, it runs on the code itself, but it does not really. I mean, you cannot really watch, let's say, this is my list of dependencies, and then I watch that, okay, new issues comes up. But I think you can look directly to this database. It's open, sort of. So you can build a script or something which monitors the database for your dependencies, and when someone comes up, maybe you want to trigger an upgrade and then a deployment, I would say. Yeah.
Thank you for the talk as well. You mentioned yourself the linter aggregators like Golang CI lint or Golang lint CI, I always confuse it. What would be the pro or a con to try to focus on a concrete tool that is in one of those aggregators and maybe go on with concrete configurations for a bunch of them, or just slapping on the Golang, the aggregated one? Because right now for us, I think we just use the default settings on the aggregator and rarely really pay attention to what happens underneath.
Yeah, I mean, they have a set of linters they integrate in there. Each linter has its own specialization, I would say. You have more generic static code analyzer. They are not very focused on security issues, but just on code issues. Or you have linters which they just find one issue, basically. So I would say I would rather run it as an aggregator than just one tool, because you get a lot more coverage. I don't know from performance perspective what's the implications, and probably you need to look into what is the default set of rules and what makes sense for you and what doesn't make sense, because there are, I think, probably 50 linters at least. What I've seen in my experience, another problem was that we did an upgrade or we did a release, and it took a while until they really integrated into the aggregator. So there is a window until they upgrade this Golang CI, for instance, to include your new version inside of the aggregator. So that's maybe to consider, but I would rather run an aggregator with a set of linters and include a security like gosec, a security linter, and a bunch of other, of course.
So the cue to disassemble the aggregator into parts would be the performance?
Yeah, I mean, you need to check if you have, first of all, performance issues. If you are happy with how fast it runs with all the checks, then I would just keep them how it is. If you are not, then you probably want to check, okay, is something which doesn't make sense here, and kick out some linters from there, I would say.
You mentioned signing the binaries and artifacts, and I would like to know which security issue you're preventing by doing this.
Yeah, so when you want to sign, it's basically you want to prove that you are the person who really released that binary, right? If you don't sign it, then someone can take your code, can modify it. Let's say if you are an open source project which is used by many people, let's say imagine in this case gosec, someone takes the code and builds a binary and someone manages to put it somewhere and then distribute it to others. So you want to check that really the source of the binary, you check that is really released by the person who claims to be. So it's like you check the authenticity of that. And that's the easiest way with the signature. And I think for container images, it's much easier because they store the signature together with the image layer into the container registry. And then when you fetch it, you can also verify it immediately, basically. With a binary, yes, you have, let's say, most likely you have an archive. You put the signature outside of that archive, and someone needs to take both, download and check that the archive is signed properly, and so on.
We got time. Okay, if that's all, it's lunchtime now, so in 15 minutes. Buon appetito, and thank you, Cosmin, again.